All right, hi year 11s, this is Mr. Lim here, and I know I haven't been here in class for a while, so I thought I might make a video on this worksheet on chemical bonding in preparation for your test. So please make sure you watch this all the way through, and if you have any questions, please send me a message on Sector, otherwise you are not going to do very well on the test, and I'm going to give you a bad mark on your interim report for seeking assistance. So please make sure you do so. All right. Just send any messages of what you don't know, what you don't understand, or what you didn't get, and I'll see if I can get back to you before Monday. Okay. So here we go. Let's go read through this test and let's go through it, or this worksheet. Please make sure that you try this before you watch this video or finish watching this video with all the answers. Try it yourself and then go through it and then understand where you went wrong and then send me a message. All right. So which of the following best statements best describes why metals can conduct electricity? So you should remember conducting electricity is based on the presence of mobile charge carriers. So what are the mobile charge carriers? They are the delocalized electrons. However, they are not just any electrons. They are the delocalized valence electrons. Okay, so they have delocalized electrons. That's technically true. Okay, they have delocalized valence electrons, which can move around and carry charge. Okay, so again, it's the mobile charge carriers, so move around and mobile and carry charge, made of a lattice of positive metal ions, which is true, but it's not the best answer. And they have a strong electrostatic attraction between nuclei, which is false. Okay, so we know it's definitely not D, but we have three true statements. Which one of them is related to conducting of electricity? Well, the first two are, so it's not C, right? And then again, it's the one that best describes, okay? So it's not A, which is, technically true, but it's not a description. It's just kind of a statement. Okay, so it's B, all right? Let's have a look, next one. Which of the following metals would you expect to have the lowest melting point? Okay, so melting point, we should remember that melting point is related to the strength of attraction between particles. Strength of attraction between metals is between the positive metal nuclei or ions and the sea of delocalized valence electrons. Okay, let's have a look at what these three things are: sodium, potassium, and rubidium and cesium. So if you look at these four elements on the periodic table, you'll notice that they're all in period 1, all right? And that means, since they're all in period 1, they all have the same core charge, and that they have different numbers of electron shells or energy levels, right? And since they have different number of energy levels, we're talking about the valence electrons will be further away or closer to the nucleus, right? Which one has the valence electrons the most far away from the nucleus? It's cesium, right? And that means that it will probably have the weakest attraction between those valence electrons and the nuclei, because they are so far away. So that makes this answer cesium. All right, so you need to have a think about, okay, what's the thing that sorts out melting point, right? And it's the attraction between it. And then what do we know about these things? And then compare them and work out logically what would happen, right? Next, a group 2 element and a group 16 element chemically combine to form which of the following compounds? Okay, so let's have a think. We have a group 2 element, and group 2 element we know turn into +2 ions. Please watch the video about how ion formation occurs. All right, group 16 elements, and please learn how to read Roman numerals. That's a 10, and that's a VI, that's a 6, so that's group 16, form -2 ions. All right, so they form a +2 if Y is +2 and Z is -2, then they're going to go together in a 1-to-1 ratio, because the lowest common multiple of those two numbers is 2, and so therefore they just multiply by 1 each, and so therefore your answer is YZ. All right, let's have a look here. The ionic lattice on the right is most likely to be which of the following ionic compounds? Okay, so what we've got here is a 1-to-1 ratio. So one of these to one of these, okay? That 1-to-1 ratio gives you the information that you need for these ones here. So potassium fluoride, potassium is a P. Potassium fluoride is KF. Strontium oxide, strontium is SR. Strontium oxide is SRO. All right. Calcium chloride, lithium chloride, LiCl, right? So not only is it the 1-to-1 ratio, but it's also the size differences. So we're going to look at the sizes. Okay, so which one has the largest negative ion? It's going to be the Cl's, all right? The Cl is going to be much larger than the F, right, and the O. So the Cl is going to be a larger one, so it's not either of these two, all right? And then which one is going to be larger? So the the smaller thing. Well, first of all, calcium chloride has the CaCl2, which means that you expect a 2-to-1 ratio, or at least the 2 minus to be shown, or sorry, the 2 positive to be shown on the gray ones. So therefore, the lithium chloride is probably the one that it's going to be because of the size differences and of the charge and of the ratios, right? Which of the following combinations correctly allocates the valence electrons in a molecule of hydrogen cyanide? Okay, so again, these bonding electrons are the ones that are between atoms, and non-bonding electrons are the ones that are not between. I would suggest you just draw this out. So hydrogen cyanide is this one here. Now you'd have to remember to take some practice to draw this out, but I know what that one looks like. It has 8 bonding electrons, which are these ones here, okay, because those are involved in bonding, and 2 non-bonding electrons, which are here, which are not involved in bonding. All right, so that's the combination that you want, and so therefore the answer is A. Okay, what I might do is quickly just go through the steps on how to draw this HCN the way that I've described it, so let's go through that. Okay, H has 1 electron, it needs 1, so I draw 1 dot here. C has 4 electrons, which means it needs 4 electrons, which means I draw 4 dots here. And nitrogen needs 3 electrons, which means I draw 3 dots there. I connect the dots, okay, so I have to connect the, I can't connect the H to the N because, oops, didn't want that. Where's my drawing thing? Here we go. Okay, if I do this, what's wrong? Right, I've connected the C to itself, so that's not good. That one there. So therefore I can't do it that way, so I have to undo that, redraw that, and look for another way to draw it. Okay, so another way to draw it would be to go, okay, I got 1 to those things there, 1 to there, 1 to here, 1 to here. All right, now how many lines are connected to the C to the N? 3. How many lines connecting to the H to the C? So 1 line there, 3 lines there. All right, then I convert each of those into a pair of electrons. So 1 pair here, 3 pairs here. All right, then I say that, okay, how many of those ones belong to the hydrogen? 1, and that was expected because hydrogen came with to the diagram of 1. Carbon has 4 there, and that's expected because it came with the diagram of 4. And then nitrogen has 3. However, nitrogen, you should know, has 5 valence electrons, and so therefore you'd have to draw the other 2, the other 2 here. All right, and that's how you get that structure there. Okay, so that's hydrogen cyanide. Let's go have a look at the next one. Okay, which of the following statements best describes why covalent molecular substances have a low melting point? Again, low melting point, this information is about, and it's a best describes again, melting point is about the strength of attraction between particles, so we have to work out why covalent molecular substances have weak attraction between particles, right? This is a true statement, all molecules are neutral, they have non-directional bonding, a true statement, a weak intermolecular forces, a true statement, and they're in fixed position and cannot move in the lattice, which is technically true when it's a solid. Right, which one is about the strength of attraction between particles? It is C. All right. A is about electrical conductivity, B is about malleability, and D is just about whether it's in a solid, liquid, or gas. All right, so that one is C, even though all of those statements are true. Okay, so let's move on. Formula for the following compounds. Now, this is why I've gotten you to try and memorize all of those ions, because you should just be able to pull out what these ions are. Sodium oxide, okay, the lowest common multiple of 1 and 2 is 2, so I bring the sodium to a multiple of 2 by timesing it by 2, and oxygen, I just leave it by itself. Magnesium is 2 plus, chloride is 1 minus, so that's MgCl2. Aluminium fluoride is Al3 plus, F minus, so therefore that's AlF3. Okay. Remember, we're going to the lowest common multiple. The lowest common multiple of 3 and 1 is 3. So the aluminium can just multiply by 1, and the fluoride has to multiply by 3. All right. Ammonium sulfate. Again, this is why we practice remembering what the formulas are. Ammonium, NH4 plus, sulfate, SO4, 2 minus, and this should actually be with an F. Okay. So that's going to be 2 NH4s, and I have to put those in brackets, remember, and then SO4, carbon dioxide. Now here's an interesting one. Carbon dioxide, is it an ionic substance or a covalent molecular substance? It is a covalent molecular substance. These have all been ionic so far. These two are covalent molecular, and these two are ionic. So they have a different naming system. Carbon dioxide, 1 carbon, 2 oxygen, so carbon dioxide. And dihydrogen sulfide, so dihydrogen, di meaning 2, so 2 hydrogens. And sulfide is just S. All right, magnesium nitrate, Mg bracket NO3 2, okay, because it's Mg2 plus and NO3 1 minus. Okay, so you need to get those two to be of the same lowest common multiple of 2 and 1 is 2. So therefore, I just have to multiply out the NO3 by 2, and I have to show that it's the entirety of the NO3 that I'm multiplying out by 2. Okay, chromium carbonate, Cr3 plus. How do I know it's a 3 plus? Because I have this information here, chromium 3, telling me that it's a chromium 3 ion, and carbonate, CO3 2 minus. Lowest common multiple of 3 and 2 is 6, so I'm going to multiply out the chromium by 2 to get to 6, and the carbonate by 3 to get to 6. And I have to make sure that I show that it's all of the carbonate that is multiplied out by using brackets. Okay, electron dot diagram. So first of all, what you should be recognizing is that you have to identify whether this is ionic or covalent. This happens to be what? Ionic. How do we tell it's ionic? Because it has a metal and a non-metal. Okay, so a metal and non-metal means it's an ionic bond, which means that you have to draw it like an ionic electron dot diagram. So the sodium, remember that it has no electrons in its outer shell because it gave up those electrons to the oxygen, 2 minus, right? Showing that some of these electrons are from somewhere else. Okay, those two there. Don't forget the square brackets and the charges. And what's missing on this one? The coefficient, right? Showing that there are 2 NAs there. CH4, is this a ionic substance or a covalent molecular substance? Okay, it is in fact a covalent molecular substance, right? So I have to follow the little thing, 1, 2, 3, 4, and 4 hydrogens. And if you hadn't worked it out, each of those hydrogens is attached to each of those little lines, which means that when I bring that all in, it's going to look like this, CH4. Okay, replace each of those lines with pairs of electrons. I checked that I don't need to add any more. The hydrogens all brought 1 electron, and the carbon brought 4 electrons. And so all electrons are accounted for in that diagram, but there are no non-bonding electrons. HClO, is this a ionic or covalent molecular substance? This is a covalent molecular because they're all non-metals. Okay, since they're all non-metals, if this has to be a covalent molecular, hydrogen wants 1, chlorine wants 1, oxygen wants 2. Okay, should be fairly quickly to draw that one out. Oxygen can have a Cl one way and a H on the other. I erase those two lines, put in some pairs of electrons, okay? And so those are my bonding pairs. And then I think, okay, well, how many are there supposed to be of each electron on this diagram? So hydrogen brought 1. That's cool, that's done. The oxygen has 2 electrons in this diagram. However, we should remember that oxygen has 6 valence electrons, right, by its position on the periodic table. So I need to add how many more? 4 more, because there are 2 already there. So I need to draw, I need to redraw in those 2. And then I need to, so what I'm saying is that you need to add those ones there to make it a correct diagram. This chlorine here, it has brought 1 already to the diagram, but we should know that chlorine has 7 valence electrons. So I need to draw the other 6 there as well. Okay, and so then I have those ones there, and that is HClO. NH3, is that a ionic or covalent molecular? It is a covalent molecular because it has only non-metals. So I have N, 1, 2, 3. It needs 3 electrons because it has 5 electrons in its outer shell. 3 hydrogens, that should be fairly easy to connect. I redraw that as, okay, maybe in the test ask for a scrap piece of paper so that you can redraw these if you need to. Okay, and then replace each of these with a pair of electrons. Okay, and then I say, okay, well, the hydrogens, they all brought 1, they have their 1. The nitrogen, it has 3 in the diagram. However, it really needs to have 5 in the diagram because nitrogen has 5 valence electrons. So I need to draw 2 more. They're the circles, They're the circles. And I'll highlight them in red so that you can see that those 2 there are the nitrogens as well. That doesn't look like 2 electrons. Okay. That looks like 2 electrons, but they're now in red, but doesn't matter. Okay, so really got to remember to identify whether these things are ionic or covalent molecular. This is covalent molecular because it's only got non-metals. Let's go draw this out. Oh, nitrogen, there's 2 of them. 1, 2, and they need 3 electrons each. Oh, look, how convenient. I just connect them all together. So therefore, I'll end up with something that looks like this. Okay, that's not what you should end up looking at. How many lines we're connecting the 2 ends? 3 of them. So that's what it should look like. Replace these lines with X's and O's. All right. Then you would say, okay, well, this nitrogen here has 3 electrons in the diagram. It needs to have 5. So I need to have 2 more electrons in that diagram to make that nitrogen show all of its valence electrons. And then over here, I got, again, the same situation, 3 here. So I'll add in another 2 on the other side to make it so that those ones have their full complement of electrons. Okay, next one here is this covalent molecular or ionic. This is, again, covalent molecular. C's have 1, 2, 3, 4, and there are 2 of these C's. Okay, and then there are 4 H's. 1, 2, 3, 4. Okay, how do I connect these? Okay, you have to use your bit of imagination. What you can see is that I could connect them all to that, but then that just wouldn't make sense because then I haven't connected the other substance, the other carbon there, so I can't do that. All right. What can I do? I can connect some of the carbons together, 1 of them carbons together, but then I have 6 extra spots there for only 4 hydrogens. So maybe I'll connect it twice. Now I only have 4 spots for extra hydrogens. That's pretty good. So I have 2 lines connecting the 2 C's together. 2 lines connecting the C's together, and then 1 line connecting the C's to this one, and then another 2 lines for this one here. Okay, so then I redraw that. Get rid of all of it, and I will have something that looks like this. Come on. And then I replace these lines with dots. So remember that because there are 2 lines connecting these 2 C's together, that one there is a double bond. All right, and you need to have both of them there for the 2 lines that were present there, connecting those 2 there. All right. So how many of these belong to this carbon? 1, 2, 3, 4. That's how many it was supposed to bring to the diagram. How many belong to this carbon? 1, 2, 3, 4. Right? This hydrogen here brought 1. 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 So there are no extra electrons needed to be drawn there. Right? Calcium nitride. Again, work out whether this is ionic or covalent molecular. This is ionic. Okay. If it's ionic, I have to draw it like an ion. So calcium, 2+, it's a positive ion. It has no electrons around it. Nitride is N3-. Okay, with a formula with 1, 2, 3, 4, 5 electrons of its own, and 3 from taking them from something else. Okay, so calcium nitride, I have Ca2+ and N3-. The lowest common multiple of 2 and 3 is 6, so I need to multiply them out to get to 6, so it would be calcium 3 nitride 2, okay? And so therefore, I would have to put a coefficient there and a coefficient there to make that balance, right? And then lithium chloride, is this an ionic or covalent molecular substance? It is, in fact, ionic because, again, a metal and a non-metal, okay? Lithium, Li1+, chloride, also a 1-. What's missing here? The electrons. So 1 electron from somewhere else, the other 7 electrons from the chlorine. All right, that makes, because it's a 1-to-1 on the charges, so therefore it is a lowest common multiple of 1, and so therefore you just keep them together, so it's LiCl. And so therefore I don't need to add in any coefficients. Right. Let's have a look at the next one. Explain the following properties. Right, so the property is metals are malleable, so we need to remember what malleable is related to. Malleable is again related to the directional bonding, whether you can move atoms and break the bond or keep the bond and still keep them together. So that's how you should be thinking about answering these. These are usually worth 3 marks, and so therefore those 3 marks are based on whether you can talk about the actual properties. So malleability is the ability for atoms within a substance to move without breaking the bonds that hold them. All right, and so I really do recommend answering in dot point as well. It just makes everything a bit clearer. So so what you should do when you're asked to explain something, you explain the property. So the property is malleability, and that's the definition of malleability. Then you start talking about how metals do this. So metals have non-directional bonding between the positive metal nuclei and the C of delocalized electrons, or valence electrons. All right. Metal atoms. Oops. Metal atoms can move by force and still have attraction between these two. Okay, so that's how you would split up that mark into 3 marks. 1 about the property, then 2 about how the whatever the question is asking, whichever type of bonding it is. All right, so let's have a look. Ionic substances cannot conduct electricity in solid form, but can in molten form. Okay, so again, this is talking about electrical conductivity, so you have to talk about electrical conductivity is based on the presence of mobile charge carriers. Please keep in the lines when you're writing in the test. Right. Presence of mobile charge carriers. So in solid form, ions are charged but not mobile, stuck in lattice. Don't write outside the lines. Right. In liquid or molten form, ions are free of lattice and can move and conduct electricity. All right, 3 marks again. Covalent molecular substances have a low melting boiling point. Again, so melting boiling point, what is that about? Melting boiling point, or melting point in this case, is a measure of strength of bonds between particles. Covalent molecular substances are made of neutral molecules, which means they're not charged, which means they don't have electrostatic attraction or permanent electrostatic attraction, with weak intermolecular forces holding them together. And then remember, for melting boiling point, you need to talk about requires a low or high, if you're talking about a high melting point, a low amount of energy to break bonds between them. All right. And then finally, graphite can conduct electricity. Okay, so this one's worth 4 marks, so maybe a little bit more detail. So always look at the marks as well. 4 marks, graphite can conduct electricity. So again, conductivity based on presence of mobile charge carriers. And I can abbreviate, you can't, so don't abbreviate in the test. Right. So conductivity is based on the presence of mobile charge carriers. Graphite is covalent network substance, which is made up of carbons bonded to 3 other carbons. Makes sheets of hexagons or graphene. the idea is that it's off sheets, okay? Then the fourth valence electron is delocalized and can move and carry charge between sheets. Okay, so that's it for this this worksheet. Please remember to just go send me a message if you have any questions about any of the topics that we've covered and you can't answer things. If you're having trouble with certain skills, please make sure you rewatch the videos and then ask and practice. Okay. Just have a go, and then the test is on Monday. Please send me a message if you have any questions, and then I'll try and get back to you before then. Adios.